Nothing. It'd be way too.
Is this stuff gonna be like No, I know. Maybe it would be like on the next. I'm sure it is. I downloaded it.
Well, yeah, so the next quiz comes after the next exam. So we'll probably do practice, because we've got today, we have tomorrow, and we have, I'm going to post the homework today. I'll probably do it from here before I even go home. So there will be homework to start to do. Oh, joy, right? What? Well, we could
We have
check.
an exam Monday, right?
Yeah, that's what I'm trying to say.
We have a test Monday.
You're taking 2 classes?
What?
You're taking 2 classes this semester?
No. We have a test Monday.
Yeah, we have an exam on Monday and a quiz on Wednesday.
Okay, yeah, that's what I was asking.
Yeah.
No, I'm not taking 2 classes.
I am.
Oh, I know.
All right. All right, this is chapter 17. Okay, it's the one that comes right after 16. And just so you are aware, this is a completely different topic than what we have been doing, okay? My original plan when I made the syllabus was to cover, as we did, 15 and 16, excuse me, 14 and 15 on the first exam, and then 16 and 17 on the second exam. However, since today is Wednesday, tomorrow's Thursday, and then the exam is on Monday, whatever we get through today is what will be on the exam on Monday, okay? So just so we're clear on that. So there will still be an exam. I don't like to change when dates are. I will revise objectives. So I may not revise actual objectives today. I may go home and let you know exactly what objectives from chapter 17 will appear on Monday. I will, last night on my list of things to do was to post homework 3. I got a lot of questions, quiz questions, so I didn't get that far. So I will post homework 3, probably that will be the first thing I will do, and so you should start doing that at your earliest convenience. It will be over chapter 17, but don't forget about chapter 16 at the rate we're going. Exam 2 will primarily be over chapter 16, okay? And there were some types of questions that were not on this exam that could, on this quiz that could show up on the exam. All right, so then, yeah. No, don't be sorry.
Are we gonna get homework 2 back before the exam?
Yes, I'll go home and do homework 2 today as well. I don't know if it's any consolation, but if you feel like you're doing chemistry all day long, I feel like I'm doing chemistry all day long too. So I don't know if that's a fair trade, but yeah, every day I sort of write it all down and it's all chemistry. So it's not like I'm going out to the beach or anything on the afternoons while you're at home studying chemistry. All right, so you may recall if you took Chem 101, and I think that's the prerequisite to have taken some type of Chem 101. If you haven't taken Chem 101 in a long time. I know some of you have expressed to me that it is a long time since you've taken Chem 101. In the module, there is an old PowerPoint from the old book where energy was studied in chapter 5. In this book, the old chapter on energy is chapter 6, okay? So if you're kind of like enthalpy and Hess's law and changes in reaction and all that kind of stuff, then you may want to do a little bit of review. We're also going to do a little bit of a review. However, we may not do enough review to satisfy whatever you've forgotten between the semesters that you took Chem 101 and this present semester. Thermodynamics. Thermodynamics is the study of the relationship between heat and other forms of energy involved in a chemical or physical process. We can put heat into systems. They can change their phases. They can change from reactants into products. And so what we want to do is we want to study those relationships, okay? And you may recall from chapter, it's usually chapter 5 or 6 in a general inorganic textbook. The first time around, you surely talked hopefully about exothermic and endothermic reactions. And exothermic reactions give off heat, endothermic reactions require the input of heat in order to take place. And you may have gotten the idea that kind of exothermic reactions kind of happen, and they just happen, okay? And that's a general truth. We're going to find out that exothermic reactions tend to happen all on their own. Endothermic reactions tend to not happen all on their own. They tend to need some input of energy, okay? And so, however, there are some endothermic reactions. For example, there are solids. If you go to the store today and you buy a cold pack, you know, maybe you have a sprained ankle or something, and you use that cold pack, that's an endothermic reaction. What does an endothermic reaction do in order to take place? It removes heat from the surroundings. The heat's transferred from the surroundings to the system, okay? And so the surroundings of that system feel colder. And so that's how a cold pack works. Now you don't have to do anything to get that reaction to happen. It's an endothermic reaction. However, it is spontaneous. So the theme of this chapter, if you would like an idea of where we're trying to go, the theme of this chapter is that we are trying to get to a place where we can tell very specifically, not just by enthalpy or by heat gained or lost,